What about multiplying normal numbers like 1, 2, 3, etc. by 10 to the power of n? 3 multiplied by 10 to the power 2 is equal to 3 multiplied by 10 multiplied by 10, which is 300. Notice that I put 3 and made the number of zeros match the power. Now 2.31 multiplied by 10 to the power 2 is equal to 2.31 multiplied by 10 multiplied by 10, which is 231. Notice that I put 2.31, but I moved the decimal point 2 places to the right since my power is 2. 0.16 multiplied by 10 to the power of 3 is 160. Notice that my power is 3 and I moved the decimal point twice to the right, and since there were no more digits after that to move the decimal point over, I added a 0. This now matches my power, 2 decimal places and 1 0. What about 0.092 multiplied by 10 to the power 3? Well, that's 92. Just move the decimal point to the right 3 times. Let us represent the radius of the sun as a number in the form of power of 10. The radius of the sun is 695,500,000 meter. You can write 6.955 multiplied by 10 to the power 8 meters. That's easier, right? What about numbers multiplied by 10 to the power of minus n? Let us have a few examples. 6 multiplied by 10 to the power of minus 2 is equal to 6 divided by 10 divided by 10, which is 0.06. Notice that my power is minus 2, and I moved the decimal point 2 places to the left instead of the right. That's the whole idea. You just move the decimal point to the left. 3.14 multiplied by 10 to the power of minus 2 is 0.0314. Notice that after moving the decimal point once, I don't have any more digits, so I put a 0 and move over it. What about 0.17 multiplied by 10 to the power of minus 3? This is 0.00017. See, I moved the decimal point 3 times to the left after putting zeros and moving over them. Now 0.092 multiplied by 10 to the power of minus 3 is 0.000092. Let us represent the radius of gold atom as a number in the form of power of 10. The radius of gold atom is 0. And then 14 zeros, then 73. You can write it as 7.3 multiplied by 10 to the power of minus 15. That is also easier than the previous number, right?